We're getting toward the end of our chemistry unit, and the title of this video is called Where Does the Matter Go? And we're going to be talking about the law of conservation. And we have looked at kind of the historic view of this. We talked Lavoisier and how they were able to prove the law of conservation by careful measurements in a closed system, that what you start with, you're going to end up with the same amount of matter. It's just going to change forms, whether that be to a gas or a liquid or a solid. You get a new chemical formula. And it's very important to understand that in a chemical reaction, matter is not disappearing or appearing out of nothing. It's not magic. The molecules and the elements just get rearranged to form something new. So the matter, and the mass of the matter, is neither gained nor lost. It just changes forms. And we call this the law of conservation of matter and energy, because it also applies to how much energy is used in the reaction. So if you think about a mathematical equation, the total number of atoms on each side of the equation have to be equal. And in chemistry, when we write an equation, we write it with an arrow, and that arrow represents an equal sign. Now, we see chemical reactions all the time, and we may not realize it. And we've talked about some of these. But when you have make a cake, and some of you may have done that over the holidays or eaten some dessert over the holidays, but you've got acid in milk, lactic acid, and you've got baking soda that you add to a cake mix, and that chemical reaction that takes place while the cake is baking produces carbon dioxide gas. When we burn a piece of paper, we produce carbon dioxide and water vapor and ashes. When hydrogen peroxide decomposes, it produces water and oxygen gas, and we proved that when the split relit. So if you look at this formula, zinc plus hydrochloric acid, and we did that when we collected the hydrogen gas in the balloon, and we watched it burn or pop as the hydrogen gas burned. What was remaining in the bottom of that flask was zinc chloride. So if you look at this equation, that arrow sign says everything should be equal. And I see one zinc on both sides of the arrow, but unfortunately I do not see equal numbers of hydrogen and chlorine. So this equation is incomplete. It's not written correctly. And for that, you would go and add what's called coefficients, where you mathematically put in the right numbers to tell us how many molecules you need. So I need 2 molecules of the hydrochloric acid. Therefore, if I put a 2 in front of HCl, I now have 2 H's and 2 chlorines, and everything's equal. So a lot of times when you see chemical reactions written, people have written down an ingredient list, but they have not written down a recipe. So that's how I kind of know the difference between whether the equation is balanced or written in correct form. If it's not balanced, then I know they've just written down the ingredient list, what molecules it's going to take to produce the products, but it's not written correctly. And to do that, you'd have to go back and add what's called coefficients in math. And if you think about the distributive property in math, that's what applies to coefficients here. So where does the matter go? If the reactants, what you start with, equal the products, what you produce, it says that in a closed system, all the mass can be accounted for. And if you think about Lavoisier's that we watched yesterday, all of the matter is accounted for. You're using equipment that is not letting any gas or liquid or solid escape. However, in an open system, if your flasks, for say, are not stopped, they don't have stoppers or ports in them, or tubing, then gas, if that is produced in the reaction, then it will escape, and it appears that there is mass loss. But it's not. That gas is just out in the atmosphere. It's just not able to be measured. So let's look at some equations that we can do together, and we'll pause right here and see if we can't figure out the answers. All right, so to review, the law of conservation says matter and energy can neither be created nor destroyed. It can only change forms. So form new compounds, which can be, or new elements, or released elements, which can be in the solid, gas, or liquid form. And when energy is exiting the reaction, or being absorbed in the reaction, we have some things happening there too. And we'll talk about that in our next lecture.